Hello students, pleasant greetings to you all. Welcome back again to yet another video from the Apex Institute of Mathematics Education. My name is Akin, your math instructor, and in today's video we are yet again going to be taking some time out here to go through a most recently administered exam that I've given to my students as we continue our extensive preparation for Csec 2023 to 2024, and this particular paper covers yet some very important aspects of the math curriculum. Of course, traditionally, in question 1 and 2 you find the more doable questions such as fractions, decimals, and approximation, and a few worded problems from the consumer arithmetic branch. But as you go deeper and deeper into the paper, you're going to find also that we're going to be looking also at factorization, solving equations, rearranging formulas, and of course then we get into the graphical aspect of the paper where we're now going to be introducing the topic of transformation geometry. All right, as we go on towards the end of the paper, as you can see here, we're going to be looking at also a little bit of geometry, using geometric reasoning to find solutions to our diagram. And we've got to also go back a little bit to the fundamental aspect. We're going to be looking at also variation, and to end this paper here, we're going to be tapping into another graphical aspect of mathematics, which is coordinate geometry. All right, so I do hope that you take the time out to spend some time with me here as we autocorrect our mistakes that we have made, which would have contributed to the grade that you got on this particular exam. So do not forget to hit the subscribe button below, turn on your post notification bell, leave some positive questions and comments. Let me know if the video was very helpful to you. Leave your thoughts in the comment section, and let's just jump right into this particular lesson today. You're going to be with me about an hour to an hour and a half. Hopefully we can run through this in a effective time frame. So let's get right into the lesson. All right, guys. So you are looking at, in fact, question number 1. And we are, of course, going to jump into the fractional aspect of this particular paper. I'm going to take my time. I'm going to walk you through this whole entire paper as meticulously and as clearly as I possibly can. And of course, my aim here is to give every student the ability to analytically understand the question. I find that many of my students, both in the past and present, are regurgitating information as opposed to understanding what you're doing when you're doing your calculation. So let's jump right into it here. So I've already written the question back over on this page here. So let's jump right into this. And we're looking at multiplication and subtraction of fractions. And we start this question off here by simply going ahead here to do all our conversion. So 4 multiplied by 2 is 8. 8 plus 1 is 9 over 4. Then we're going to be multiplying this then by 4 over 5. Okay, so there's not much to do here. And then we're going to go ahead and divide this then by 3/5 minus 1/2. Okay, so we're going to be working out this section in stages. We're going to be working out the top section. So what we have here is 9 over 4 multiplied by 4 over 5. Of course, when we are multiplying fractions, we're gonna look for common factors to cancel our numerators and denominators. So say here 4 into 4 one time, and 4 into itself also goes one time here. So we're left with the simplified answer of 9/5 at the top of our equation. Let's just call this, say here, part A. So this is part A. Okay, so this is part A. Let's move on then to, say here, part B. Right, you work these questions in parts. So part B then is a simple application here of finding your LCM. So if we go back here to grab our black So here we have, this implies that this is 3/5 minus 1/2. Then we're going to be finding the LCM. The LCM of 5 and 2 here is 10. So that's 5 times 2 is 10. So 5 into 10 goes 2 times. Multiply the top here by 2. 2 into 10 here goes 5 times. Multiply the top here by 5. So 3 times 2 is 6, and 1 times 5 is 5. We end up with a result here of 1/10. So now we're going to be dividing the answer that we got in part A by the answer that we got in part B. So with part A here, we got 9/5. So that's 9/5 divided by 1/10. Okay. And this is in fact going to be 9/5. We're going to be reciprocating, or we're going to be changing the sign to multiplication and reciprocating the last fraction. So that becomes 10/1. So once again, if we're multiplying fractions, we're going to be cancelling numerators with denominators. So that's 5 into 5, 1, 5 into 10, 2 times. So our final result here of part A divided by part B here results in being equal to 18. 9 times 2 is 18. All right, so I find that there was a lot, most of my students were successful. A few students did make some very unusual, uncharacteristic mistakes, which would have led them to not getting the complete answer here that we're looking for, which was quite easy, as you can see, to get through here. But of course, hopefully that little explanation there would give you some clarity on what you have done incorrectly. Let's then move on to the decimal aspects. So here, this is also a rather interesting question in terms of the solutions that some of my students got. I think a good amount of students did in fact get this right, but quite a few students were caught by the fact that they completely forget about the fundamental concept of PEMDAS, and PEMDAS applies right throughout all aspects of your numerical calculations. Here we are asked to multiply the square root of 21.4 by the square of 2.11 and then subtract the answer from 18.5. Still, we have to use PEMDAS. And so for those who do not know what PEMDAS is, please be reminded that we have a tutorial video on my channel that talks about PEMDAS. So that is PEMDAS. There are no parentheses in this question, so we know that we're going to be xing off the P. Okay, so let's x off the P here. And there is an exponent, so this is going to be the first part of the problem we're going to do. We're going to be doing the exponent. Then after completing the exponent, we are obviously going to have to do multiplication next. That's the second part. And then of course we're going to be doing, there's no division, there's no addition, and then we're going to finally do the subtraction aspect of the problem. A lot of students got caught not getting the full 2 marks because they actually subtracted before they multiplied. Hence, therefore, you would have gotten your answer incorrect. But let's jump right into it here. Of course, I like to take the question down in sections because my video primarily guides students on making the correct approach every single time. So this is not a run-through type of video. I'm here to guide you with exactly what you need to think about when you see these questions. So here we're going to be just rewriting our 18.75. And our subtraction sign, we're going to be finding the square of 2.11. So let me grab my calculator here. So that's 2.11, and we're going to be squaring that. We should get 4.452 here. Okay, multiplied by, this is also an exponent, square root, cube root, they're also exponents. So we're going to go ahead and find the square root of, say here, that's square root of 21.4, and we get 4.626, okay, approximately. So then here is where a couple of my students got caught. You actually went ahead and you subtracted the 4.452 from the 18, which gives you, that's where you all went wrong. Here's where you have to remember that multiplication comes next. So that is 18.75 minus the product of these two. So that's going to be 4.626 multiplied by 4.452. And we get 20.5595, okay? And then we're gonna go ahead then and say 18.75 take away 20.595. We should get an approximate answer here of say here equal to negative 1.845. Now the question did say to us here that we should in fact leave our answer correct to 3 significant figures. Was that it? Yes, correct to 3 significant figures. So to 3 significant figures, what we're looking at here is in fact cutting off here after the 4. So for this, we're going to be drawing a vertical line in between the 4 and the 5 here. Check, this number is actually greater than or equal to 5. Well, it's equal to 5. So our rounded answer is going to be negative 1.85. We just add 1 to the number before, and that gives us our approximate answer that we're looking for. All right, so nice question there. Yet again, these are the type of questions that I find a lot of Caribbean CSEC students take for granted. These are 2 marks, 1 marks, they count up. But if you're getting these questions incorrect, if you are getting these questions incorrect in this level or this level of preparation, then you have some serious working out, serious practicing to do. These questions should be run through within 2 to 3 minutes, shouldn't take you too long. So hopefully you guys are not making those errors going forward in your next exam. All right, then we're going to be moving on to say here the next question. So the next part of this here, we're going to be doing a worded problem. And so in this question, we're looking at the fact that a loan of $23,500 was borrowed from a bank at an 8% per annum, 8% per annum. Okay, we are asked to calculate the interest on the loan at the end of a 15-month period. All right. And part 2 says that you need to calculate the total owing at the end of the above period, which is the 15 months. And then we go on to say that a payment of $9,300 was made after that period, determine the outstanding balance, so on and so forth. All right. Now, I threw in a couple of things that I knew would have caught a few of my students off guard. I had to test their thinking. And what I find in my analysis after this particular question is that most of my students were regurgitating the formula. They didn't really show that they understood what they were doing. A few of my students forgot to divide by 100. They're getting some numbers that actually doesn't make sense. For example, if you're going to borrow a loan of $23,500, would you expect that the interest would have been 280 something thousand or 233 or 35,000? I find that a lot of students, as they calculated, they didn't really understand the figures that they were getting. So let's look into this question then and see what happens. Now, the mere fact, I had one particular student who did the question perfectly, but they applied the compound interest formula, and that is Nesbet. So Nesbet, you made that error, that's why you got the question incorrect. If you get a worded problem and it doesn't specifically say compound interest or compound anything about compound, then you're going to be using the simple interest formula, which we can safely say then at this point that is SI is equal to principal multiplied by time multiplied by rate divided by 100. Okay, And so therefore then the principal would have been the amount that you borrow or you invest, which in this case is 23,500. The time here is 15 months, and this is what I use to catch quite a few of my students. They completely forgot that the interest is given per annum. So we have to calculate 15 months into years. So that would be 15 divided by 12. All right, and then the rate is of course 8, and everything then is divided by 100. All right, a few students got it right, but also a few students got it wrong. So here we have 23,000 multiplied by, if you could drag down the 12, so you divide by 1200. Or what I find that a lot of students did is that they said 23,000 and they wrote 1.25. So that's let me get some space here, guys. So that's going to be 23,000. What they did is that they said 23,000, pardon me. Okay, so it was 23,500 times 1.25 multiplied by 8 all over 100. All right, now I particularly do not like working with decimals. I only work with it if I have to. So this 1.2, I find that a couple students did write 1.3, some wrote 1.2. You know, you have to write the exact value of 15 divided by 12, which is 1.25. I did give some of you half mark for actually writing down that aspect, okay, because you did show that you understood what needed to be done, but you made the error with the 15 divided by 12. Now, I would not have used the decimal if it was me. I would have simply just brought down the 12 and multiplied by 100, which then would give me a divisor of 1200 as opposed to 100. Nevertheless, then, quite a few students here did in fact get $2,350 as the interest, and that logically makes sense because that's about the correct amount of interest that you're going to be expected to charge on such a small amount that you borrow. All right, so that answers part 1, the interest on the loan at the end of the 15-month period. We want to know the total owing at the end of the above period. So remember that in the initial stage you would have actually borrowed, say here, 23,500, and you will just charge interest of 2,350. So therefore that would have given you a total amount here of $25,850. That would be the amount that is currently owing at the end of that period, the interest plus your principal. Now part C here then looks at the fact that a payment of $9,300 was made at the end of that 15-month period. So the next day then a payment was made. That means if this is a loan and you made a payment of $9,300, then it means that the outstanding balance would have been what you currently have in the account. So the outstanding balance here, this is part C. The outstanding balance would have been the outstanding balance would have been equal to 25,850 minus what the payment that you made, which is 9,300. Okay, and then therefore that would have given us a total here of $16,550. That would have been the outstanding balance. All right. And then of course they want to know the interest charged on the outstanding balance. We're going to be calculating this at a 1-year period. So in 1 year after borrowing this, how much would have been the interest charge? It would have been 8% over 100 multiplied by 16,550. And so when you guys did the calculation, I have the solution paper somewhere here. 8 divided by 100 multiplied by 16,550. Then you find here that the interest charge would have been $1,324 charged on the outstanding balance. All right, so I'm not sure why a lot of my students made I think they didn't understand the question, right? So we definitely want to work on understanding more about what we're doing as opposed to regurgitating the formula and the formulas and the copied examples. All right, you want to understand what you're working out as you work it out. So couple of marks thrown away there. Hopefully you guys are better at it in the future. Moving on then to say here question 2. I did take my time and went through question 1. Hopefully that was clear. Let's dive into the algebra part of this particular paper here. So now what we're looking at then is in fact 12x squared minus 108. Part B, 6p minus 9ps minus 6qs plus 4q, and the last one here is 3x squared minus 8x plus 4. Now, one of the challenge when it comes to this part of the paper, even on the external Csec exam, is the ability for the students to identify the different factoring techniques that is required to get to the solution. Now, for part A, let's take a look at part A. We have to go back to our algebra knowledge where we know the difference between the HCF method, the grouping method, the difference of two squares method, and the quadratic factoring technique. All right, and there's always a feel or a look to these type of questions. For example, you can easily identify that part B here is a grouping question, because grouping factoring questions most likely has 4 terms. Okay, 4 terms. So you have to be very good at factoring by grouping to get the answer for part B. For part C is a very, very renowned question. It is the quadratic expression using the AC method. And so for this particular question, it is easily identified by the square that is at the front, the term without the square in the middle, and the constant at the end. So it always has this ax squared plus or minus bx plus or minus c feel to it. Okay, and for part A, which is probably one of the hardest type of questions to identify, if we're going to talk about difficulty level of the question, identifying that part A is a double factoring method here, where we're looking at the HCF method along with a little bit of difference of two squares. So if you don't know the different types of factoring techniques, you need to get familiar with them. I do not have a video on grouping method, nor do I have a video on difference of two squares. I'll be making those soon for you. Let me know in the comment section if you want me to do so. But I do have a very elaborate video on my channel in regards to quadratic expression. A link will be pinned in the description or in the comments down below. So click on that and check that tutorial out on how to factor a quadratic expression. But let's dive into it then. Let's have a look at these questions then. So getting into the meat of the matter, how do I actually know that this is a difference of two squares mixed with another factoring? Now, difference of two squares meaning that there's a difference sign, a subtraction sign between two terms, but both terms must be able to be expressed to a power of 2. Now, there is no number that you can square to get 12. Well, there is, but it's irrational. And there is no number that you can square to get 108. There is, but it's also irrational. It's a decimal. We're looking for the possibility of having a single number that, if squared, will produce the result of either the 12 or the 108. And there is none. So the only thing left here is to check to see if there's a common factor between 12 and 108, and it so happens that 12 is a common factor. Now, if I factor out the 12 from 12x squared, I'll end up with x squared, and then if I factor in the 12 into the 108, we're gonna get 9 times 12 times 9 is 108. Now, if you pay close attention to what is in the bracket, you'll recognize also then that it's not yet completely factorized, because x squared 9, there is in fact a number that you can square to get 9, and that's going to be 3 squared. Now, the moment I'm able to express both of my terms to a power of 2, then it means that I'm now dealing with a difference of two squares. I'm finding the difference between two perfectly squared terms, and the rule is that we open two separate parentheses insert a plus in one and a minus in the other, and of course x squared is split in both brackets, so that's x here and x there, and 3 squared is split in both brackets, that is 3 here and 3 there. And that is how you factorize that particular expression. Do look out for the video, a thorough explanation on difference of two squares coming up to get a more clear understanding of what this expression is and how it's identified. Next, then we're going to be looking at this grouping method as we had discussed earlier. Grouping expressions. When you're required to use a grouping technique in math is when you have 4 terms that can be easily placed in a group of 2 like this. Now, once they're in a group of 2, the aim is to factorize the brackets individually, and provided that we end up with the same things in the brackets, then we know that we're on the right path. Now, let's have a look at this here. First, we have to ask ourselves, are the terms already grouped or do we need to regroup? Well, it so happens that this particular question does not require us to regroup, because first bracket here, we can see that there's a clear common factor of 3. 3 can go into 6 and 3 can go into 9, and there's also a repeated term here of p, so p is also a common factor. We're then going to open the bracket here and we're going to divide the 3p into the expression above here, so that's 3p into 6p goes 2 times, and 3 into 9 will go 3 times, and the p here divides into the p, leaves us with s, so we end up with 2 minus 3s in the first bracket. We're then going to go ahead now and try to factorize this expression here on this right side here. Remember that whatever we factor, we must get the same things in the bracket. So the common factor here is always going to be minus, say here 2. 2 can go into 6 and 2 can go into 4. And we also see a repeated term here of q, so that's 2q here. Open the bracket here. 2 into 6 goes 3 times, and q cancels q, leaves us with s. Negative into positive, so that's negative into positive gives us a negative, and 2 into 4 goes 2 times, the q cancels the q. Aha, now we have a problem, and this is what catches a lot of my students in the exam. They did get the full mark, they did get the mark for writing down the correct answer, but what most of my students did not realize is that we end up with 2 different things in the bracket. And if you look very closely, it might feel like it's the same thing, 2 minus 3s, 3s minus 2. They are not. Some students will say, but sir, they only turn around or they turn backwards. They're not actually. For the one in the bracket here, the 3s is negative, and for the one over here, the 3s is positive. For this one here, the 2 is positive, and over here the 2 is negative. So if we don't get the same things in the bracket, it means that we have basically made an factoring error. What is the factoring error? It's not necessarily a factoring error, but it's a little glitch in the way how our terms are arranged. Now, here is where I advise my students that if you do not get the same things in the bracket, then what is required here is for you to regroup. So that's how you know when a regrouping is required. So we need to regroup our terms. Now, it's a personal choice. Do you want to regroup the 6p? Do you want to put the minus 9ps at the front and the 6p at the back? Or do you want to put the 4q in front of the 6qs? My best bet here is that I'm always tempting to fix this bracket over here. Alright, so since I know that this is 6p minus 9ps, and that bracket is okay. If I can somehow turn around these terms and put 4q at the front and minus 6qs at the back, then what I'm going to get in the bracket is going to be also flipped. So I'm going to end up with 2 at the front, 3s at the back, and it should look the same way. So let's go ahead and do that. Okay. So now here we're going to do this, and common factor here is once again here 3 as well as p, and then we're going to open the bracket here. 3 into 6 goes 2 times, p cancel p, correct. Then 3 into 9 goes 3 times. The P cancel the P, leaves us with S. We got back the same thing we had at the top. Now, our aim here is to try to get the same thing in the bracket on the right. So the common factor here is in fact going to be plus 2. And also the repeated term of Q. 2 into 4 goes 2 times. Q cancel Q, take away. Positive into negative is negative. 2 into 6 goes 3 times. Q cancel Q, leaves us with S. And now we are in perfect shape. Perfect shape that we have same things in the bracket here. Alright. Now, can you see that you have to regroup before you make this mistake here? You can, depending on your experience, but sometimes a little bit of trial and error is what you need to make that correction. So if I did not make this error here, then how am I going to learn? All right, so now you know that whenever you have two different things in a bracket, all you have to do is just regroup one of the pairs. Now finally, since 2 minus 3s is the common factor, then we take that out as a common factor and we write what is left. 2 minus 3s divides into this term here, leaves us with 3p, and 2 minus 3s divides into this term over here, leaves us with 2q. And that expression has now been completely factorized. All right, beautiful. So a couple of things we had learned there. Now we're going to be looking now at this quadratic expression, and a lot of my students literally did not even approach the question. If I'm to think back at the solution paper that I saw today, I think less than 20%, if so much, would have got this question. Some persons took a complete wreckage of the question. They tried an approach that wasn't even thought. So lots of students here would have gotten this question wrong on this exam paper, and hopefully this explanation here will guide you all. All right, now here this is a quadratic expression, and as I said, there's a complete video on my channel. The very first video in my playlist below on algebra, you're going to find a video on this. Go ahead and check that video out to get a thorough review on the rules, the steps, why we do what we do to get to this, to factorize such an expression here. Now we're looking here at the very first thing we need to do here is to form the product of A and C. So this is therefore A here multiplied by C here. So that's 3 multiplied by 4, and that will give us 12. Now we need to therefore go ahead and list the factors of 12. So the factors of 12 are pairs of numbers, or pairs of factors that will produce the product 12, and at the same time gives us a result of minus 8 when we add or subtract them. So we're going to start with 1 and 12. 1 times 12 is in fact 12. 2 times 6 is in fact 12, and of course 3 times 4 is 12. Now our aim is to choose one of this pair, the pair that will produce minus 8 when we add or subtract. Now adding 1 to 12 we get 13, taking 1 from 12 we get 11, so that won't work. 3 plus 4 is 7, very close but not close enough. 3 from 4 is 1 or negative 1, that won't work. Now 2 from 6 is negative 4 or 4, but 2 plus 6 is 8. Now remember that our focus is getting minus 8 and not just the 8, so we need minus 8. Now obviously if we add both of them, we're not going to get minus 8. We're going to get plus 8. So if when we add both of them, we do not get negative 8, the next best thing to do here is to put a negative sign before both of them. All right. So therefore, we're going to have a negative 2 here and a negative 6 here. That will produce negative 8. And of course, when you multiply them, you're going to get positive 12. So therefore, that gives us what we need. So now we're going to go ahead then, and we are going to say 3x squared. We're going to replace this minus 8x here with, say here, minus 2x, or let's say minus 12x, pardon me, minus 6x, minus 2x, and then we're going to bring back down our plus 4. So I have not changed the question. I've changed the way how the question looks by splitting this minus 8 into two smaller factors of minus 6 and minus 2. Now we're going to go back to what we were doing earlier, that is factorizing by grouping. So here we know that factoring by grouping requires 4 terms. So in the first bracket here, we're going to end up with a common factor of 3 between the 3 and the 6. And of course, you see that x repeats itself. 3x divides into 3x squared, leaves us with x. And of course, 3 into 6 goes 2 times. X obviously cancels x, or x into x goes 1 time. Alright, common factor on the right side here is minus 2. Open the bracket. Minus 2 divides into minus 2x, goes x times. Minus 2 into positive 4 goes minus 2 times. 2 into 4 goes 2 times. So notice then that we end up easily with the same things in the bracket. They are the repeated factor, x minus 2. And obviously what is left then is 3x minus 2. And that there is completely factorized. All right, so you can therefore go ahead and check out the tutorial on that particular question. It would be most useful to you. All right, so we've taken care of the algebra section of that paper. Let's move on. We are about 40 minutes into this video. Do feel free to take a little break and of course refresh your mind. Maybe you're getting a lot more clarity than you thought you would. So take a little break and we're going to come right back to this particular question here. Let's take a break. All right, guys. So welcome back. After that refreshing break there, let's jump right into the part D of this question here. All right, x minus 3 divided by 3, take away x minus 2 divided by 5. I think I already have that question written up here. So we're still on algebra, but we're moving away from algebraic expressions into algebraic equations here. So for this particular question here, which of course I have a tutorial video on this topic here, or do I? I'm not so certain. I would have to check my playlist. But here you're required to find the LCM, all right, because we're simplifying, not solving. So the LCM, we just draw a divisor line here. Now we say 3 into 15, and what I didn't find is that I find a lot of my students using this type of technique here, which I strongly do not recommend. 3 into 15, they tend to do this thing here, times 5 and times 5, and then they say 5 into 15, they put times 3 here and times 3 here. And whilst that may work, right, and you're going to be fortunate to get the answer sometimes, a lot of the times when there's a minus between the two fractions, the two algebraic fractions, a lot of times students forget that this minus here actually belongs to this 3. So they tend to just multiply by 3 as opposed to multiplying by minus 3. What I do recommend though is that once you do the division here, so once you go ahead and you say 3 into 15, I recommend that you write the answer at the bottom of the line here and bring down the denominator here. That's 5x minus 3. And when you say 5 into 15, you're going to bring down your sign here. So that's 5 into 15 goes 3 times. And this is going to be multiplied by x minus 2. So now by doing it this way, you find that when you're distributing, as opposed to distributing the 3, you're actually distributing negative 3. A lot of the times the error is made in this line coming up next. So here, now we're going to be distributing the 5 with the both terms here, and we're going to be distributing the minus 3 with the minus 2 here. So 5 times x is in fact 5x, and 5 times 3 is 15. Okay, and then we have negative 3 times x is negative 3x. And when you use that technique with the red 3s and the red 5s at the top here, then students tend to write down 3 times this is in fact minus 6, when negative 3 times negative 2 actually gives positive 6. This did in fact catch a few of my students. Of course, being the lenient teacher that I am, I did in fact give them marks for their effort. But in the future, please ensure that you do it like this to make sure that you're on safe grounds. All right, now we're going to be grouping like terms here. 5x minus 3x, just shifting the terms around a little bit. Minus 15 plus 6 all over 15. And finally then 5x minus 3x is 2x. Lots of my students got minus 21 here, but in fact it's supposed to be minus 9 all over 15. All right, so that there is my solution to that simplification. All right, so let's hope that we got some clarity on that. Let's move on to the next question. Now, this particular question here, I was in fact quite impressed with a few of my students who actually got the question right. I was a little scared in terms of, giving the students based on where we're at and your experience. This video is not made for necessarily a student who is very good at math, but this is made for my students that I'm currently teaching in this particular year. So whilst a lot of you guys who may be watching think that this question is an easy question, do find that a lot of students will find this particular type of question here a little bit challenging. So how do we approach this question here? First of all, we have to make, I believe it was R the subject. Let's double check on that. Let us double check on that. I think it says that we should express R as the subject. Yes, it says express R in terms of pi and x. So how do we do that? Of course, firstly, we must get rid of this pi plus R from the bottom. Now, I do strongly recommend that you just simply write the x over 1 here and you cross multiply. Okay. So we have pi. So we have x multiplied by what is down at the bottom. And that's going to be equal to 1 multiplied by what is at the top. Gives us exactly what is at the top. And why did I do it like this? As I recommend students that whenever you're multiplying a term by a binomial expression, a lot of times you guys forget to multiply both. So when you do it like this, it will constantly remind you that whatever is on the outside should be used to multiply what is on the inside. Do check out my tutorial video on the distributive law in algebra. So pi times x gives us pi x or x pi, whichever way you want to write it, pi x, and x times r gives us x r here. That's therefore equal to pi minus r. Now we have a single line equation. Remember that our focus is trying to get r as the subject. So of course, if we need r to be the subject of this equation, the aim is to get both r's on the same side. So now we end up with xr here. All right, we're going to bring this minus r over here and we're going to end up with, in fact, here plus r. And then of course, notice I did not touch the pi here, and then I'm going to bring over this pi x over here. My concern here is to actually get the r's on one side. I quite frankly do not care what happens on the right, as long as my signs are correct. So whatever order you want to write it down in, it will not affect your end solution. All right, now we're going to be factoring the r because there's two of them and we're not allowed to add unlike terms in algebra. So xr cannot be added to r. We're going to factor out the r. Factoring out r divides into xr gives x times, and r into r goes 1 time. So that's r into r 1 times, and that's equal to pi minus pi x. I did have one student though that completely misunderstood the question. I believe I won't call his name, but yes, he knows himself. He replaced the value of pi 3.14. That is absolutely unnecessary. We're not solving the equation, we're rearranging the equation. So if you're that student who actually replaced pi with 3.14, that was completely not needed. All right, we don't need the value of pi. Our focus is trying to isolate r. Now to wrap this question up here, we end up with isolating r by simply dividing both sides of the equation by x plus 1. So if I divide here by x plus 1, I also have to divide the right side here. That's pi minus pi x divided by x plus 1. And by cancelling this x plus 1, r is therefore now isolated. So r is equal to pi, take away pi x, divided by x plus 1. I will be making a complete video on transposing of a formula, how to rearrange an algebraic formula to create a new subject. So do look out for that particular video. All right, we're going to be extensively diving into how to rearrange any and every type of algebraic equation or formula. All right, beautiful. So that is in fact our solution to that question here. All right, moving on next then to this part of the paper. We're going to be solving this equation, and this is something that was recently explained to a lot of my students. Here we are solving for x, and there's a couple of things that I did in fact expect my students not to make the error with, and one of them is in fact always keep your eyes on the prize. The prize is to get x to isolate x, and our subject should usually never have a negative sign in front of it. We need to do a transposition to get it to become positive. I strongly recommend that at all times avoid leaving your subject negative, or you may have to remember that subtle information of reversing the sign. We don't want to have to remember that, so always keep your subject positive. Now, first thing here is that the 4 and the 3 is a problem. That's what immediately is making the question look a bit challenging. If we can somehow find a way to eliminate the 3 and the 4 at the same time, then it makes our road to the answer easier. So the only way to knock out the 3 and the 4 at the same time is to find the LCM of 3 and 4, and in this case it is 12. So now we're going to be solving an equation, we're going to be multiplying. So as a result, when I say LCM, most times I find that a lot of my students go right ahead and be drawing a line like that, and whilst that is not mathematically correct when you're solving an equation, right? Mathematically it's not correct, but a lot of teachers allow students to get away with the whole idea of drawing a line. The only time you actually draw a line and write your LCM under the line is when you're simplifying the expression. But the moment you're solving the equation, you need to go ahead and multiply all the terms by the LCM. So that's 12 multiplied by 5 over 3, and that's going to be, you're going to take away 12 multiplied by 4x, and that's going to be less than or equal to 12 multiplied by 7 over 4. So why did I multiply everything by 12? Because the equation must be kept balanced. If I'm going to shrink the equation, then I'm going to be shrinking all the terms by the common multiplier. And of course, if I'm going to magnify the equation, I'm going to multiply every term that is in the equation by the same multiplier. So now easily then I can use this 12 here, as you're going to see here, and knock out the 3 and the 4. So 3 into itself 1 time, and 3 into 12 4. There's nothing to knock out here. 4 into itself 1 time, 4 into 12 3. So in one line I was able to knock out the 3 and the 4 simultaneously. Then we're now left with, say here, 4 times 5 is 20. Take away 12 times 4x is negative 48x, and that's less than or equal to 3 times 7 is 21. Okay, now here is where I find that a lot of my students also tend to make the error, and I'm not going to call it an error. I particularly like when my students just take a very smooth approach to the answer. Now, for the purpose of learning, I'm going to show you that doing it both ways can get you to the answer, but one is more effective than the other. Now, here is where I'm just going to traditionally do what students would be tempted to do by bringing over the 20. Now, for the students who would have decided to bring over the 20 here, then you would have easily end up here with negative 48. X is less than or equal to 21, take away 20, and that is fine. That is perfectly fine, perfectly correct. So you end up with negative 48, x is less than or equal to 1. And then of course, here's where the problem is. Many students will forget that once you're dividing an inequality by a negative coefficient, so here we're going to be dividing both sides by negative 48 to isolate the x. Many students forget that they have to reverse the sign. So they have to reverse the sign to being equal to now 1 over negative 48. So most times when a student work this out this way, leaving the subject negative, they cancel. They end up with, say here, x is in fact greater than or equal to negative 1 over 48. Just the reversal of the sign is what will allow them to get it incorrect. Now, how can I avoid having to remember to reverse the sign? My recommendation, students, so the answer is negative 1 over 48. Let's just erase here and go back to trying to make this easier. Here is where, as opposed to, say here, isolating and leaving my subject negative, I'm going to just move the subject towards the right here and move the 21 towards the left. You might say then, sir, it's not the same thing as doing it on the other side. It is, but I'm already not having to think about reversing my sign, because I'm going to end up with 20. Take away 21 is already greater than or equal to 48x. So already I know that my sign needs no reversal, because 20 take away 21 is negative 1, is less than or equal to 48x. And so therefore, if I divide both sides by 48, so that's negative 1 divided by 48, I don't have to reverse my sign. Because of course, the only time we reverse the sign is when, say here, you're dividing by a negative coefficient. I'm dividing by positive 48, so already my answer here is going to be already found. All right, so there you can see, as I said, it's a personal preference. My recommendation, always keep your subject positive. Always keep your subject positive, because that will have you a little bit more space, brain capacity to store other valuable information here. All right, so glad you got some clarity on that particular equation there. For those of you who got it right, give yourselves a thumbs up. Let me know in the comment section. And if you did not get it right, but you got some clarity, also leave me your thoughts in the comment section. It would be greatly appreciated, and we can create a bit of engagement and learning experience for new and upcoming students. All right, so let's move right along now into the graphical application of this particular paper. And now we're going to be looking at transformation geometry, and this is a recent topic. I do not have any form of tutorial on this, so of course in the future I'm going to be trying to make contents on this. Let me know also in the comment section if you think that a video on the whole concept of transformation geometry might be helpful to you here. So here what we're looking at is question 3 that says the point P11, Q41, R42 and S14 forms the shape of a trapezium. You are required to plot the following points and draw the trapezium. So let's go ahead and do just that. We already have a graph on screen here. So 1, 1, 4, 1, 4, 2, 1, 4. Let's look at that. So that's going to be, say here, let's grab this graph. All right, so this is looking at 1, 1. So here we have 1, 1. So this is 0, obviously. So that's 1 to your right, 1 to your left, 1 to your right, 1 up. 4, 1. So that's 1, 2, 3, 4, 1 up. 4, 2. So that's 1, 2, 3, 4, 2 up, 1, 2. And let's go ahead then and plot 1, 4. So that's 1 to your right, 4 up, 1, 2, 3, 4. So then we end up with this particular type of shape here. Let's just draw that. So we're going to be drawing, say here, it in green. So boom. Here. This here and here. Beautiful. So this is P. This is Q, this is R, and this is S. All right, that is our shape then. All right, those are our points. Now let's go back to the question then. We've just plotted our points and we have in fact drawn our diagram. So I gave 1 mark for plotting, I gave 1 mark for the correct drawing of the axes, and I gave 1 mark for you to connect the points. That was a 3-mark question there. Part B here says that the trapezium undergoes two separate transformations, and two separate transformations, which is a reflection across the line y equal x, followed by a let me see here, followed by a translation by the vector minus 5. Our task is to calculate the coordinates of the images after each transformation and draw them on the graph sheet that is given to you. So all my students were provided with a graph paper. Now, when I was teaching this topic, I tend to make it a little bit easy for my students. So what I did in fact do when I was teaching this topic is that I kind of told my students what happens after each transformation. So in the notes, I would have already discussed with my students that if an object is reflected, so okay, so let's just do this here. If an object is reflected across the line y equal x, then you're gonna find here that any random point, say xy, goes through that reflection will become yx. The points will interchange position. Now, the correct way to teach this is to show a student that the reflection metric, and this can be a lot for a lot of students, this can be a challenge. The reflection metric for y equal x is in fact 0, 1, 1, 0. All right, so that is actually how we're supposed to like tell you the reflection metric. And so you're supposed to use your skills in matrices to actually go ahead and use 0. So pardon me. So we're supposed to go ahead then and use the correct way that the textbook would show you, or anybody else on YouTube teaching this topic would say that you go ahead and use the matrix 0, 1, 1, 0 and multiply it by the points. Say here 1, 1, 4, 1, 4, 2, and 1, 4. And then of course by going row and column, you're gonna get, when you go row by column, row by column, row by column, row by column, and then you go row by column again at the bottom. So second row, first column, second row, second column, second row, third column, second row, fourth column. When you go through all of that, that is with the understanding that you have matrices knowledge, then you're going to end up with a result here of 1, 1, 1, 4, 2, 4, and 4, 1. Now, for my particular students, I kind of did not show them how all of this is done because we have not yet done matrices. So I had to use a more shortcut method by telling them exactly what happens after the reflection. So I told my students that, of course, any random point that goes through a reflection in this line the points will interchange. So all they had to do here was just simply take each point. So this is my method. They will take each point 1, 1 and flip it so it becomes 1, 1. They'll take 4, 1, flip it and become 1, 4. They'll take 4, 2, flip it and it becomes 2, 4. And then they'll take 1, 4, flip it and it becomes 4, 1. All right. So some of my students, they didn't remember the flip, but some of them also changed the sign. Some change the sign of 1, some change the signs of both, some change the signs of the y. So that also is where you guys may have went wrong. You did not remember exactly what happens after the reflection. So provided that you can do that, then this question shouldn't be a challenge. So we're going to go ahead then and plot the following ones that I'm going to be circling here in red. So after plotting this, plotting this, plotting this, and plotting this, we should actually end up with the object going through a reflection of y equal x. So let's go ahead then and use a color. Let's use the white here to see the difference. So we're going to go ahead and plot 1, 1. So 1, 1 is actually going to be right here also on P. So this is gonna be P prime, same place. All right. Then we're gonna go ahead then and we're gonna be looking at, say here, 1 4. So 1 4, so that's 1 4, so that's Q prime. So Q prime, S becomes Q prime, so they're on the same point. All right. And then we're gonna go ahead and plot the next one here. 2 4, so 2 4, so that's gonna be 1 1 2 4 1 2 3 4. That's right up here. So that's right up here, 2 4. Remember that S is already Q prime, so this is R prime right here. And then we have the final one here, which is going to be 4 1 as well. So it's going to be 4 1 right here, 4 1. So 4 1. So it's going to be right here. So P Q R. Q is going to become also S prime. So basically it's like the shape is overlapping our current shape. So what we're looking at here is in white broken lines, and this would have tricked a lot of my students because most times they can clearly see the reflection, but this one here, there's a slight overlap with the original shape here. So that's why I have it here in broken lines in white. And why this is so, it is simply because our line of reflection y equal x basically runs right through the middle. It basically runs right through the middle of the original shape. So basically is that the shape is kind of overlapping. Here is the line y equal x. Okay, that line runs right through the vertices of these 1 by 1 squares. Okay, so you can see that there's a clear overlap. So that's why you're not really seeing it clearly. You're not seeing, like, you can see that the bottom half of the green one went up at the top and then the top came down at the bottom here. So you're not seeing it clearly, but the line of reflection here, the mirror line, runs right through the middle of the original object. All right. So that is what happens after the reflection. Okay. Now it says that it's two separate. It says that it is two separate reflection, two separate transformations. So the first one is that it got reflected across the line y equal x, then it was followed by a translation by the vector minus 2 5. So let's jump into our calculation then here. So if we go back to here, you'll realize I'm going to go at the top here. So let's look at the points. 1 1 1 4. So that's 1 1 1 4. So that's 1 1. So that means P prime is still 1 1. Q prime is 1 4. R prime is 2 4. And S prime is 4 1. And these are the points after it went through a reflection. So obviously now both of these now here, P prime plus the vector will give us P double prime. That's the second image. All right, so that's P prime, that's 1 1, will be added to minus 2 5. And then that will give us P prime. So that's 1 plus minus 2. That's minus 1. And 1 plus 5 is 6. So that's going to be our second image. That's P double prime. The same procedure is going to be like Q prime plus the translation vector gives us Q double prime. So that's going to be 1 4 plus again minus 2 5. Because remember that the formula for translation is the object plus the translation that gives us the image. So 1 plus negative 2, that's negative 1 again, and 4 plus 5 is in fact 9. Same procedure for R, so that's R single prime plus the vector gives us R double prime. So we're going to end up with R being 2 4 being added to minus 2 5, and we're going to end up with, say here, 2 plus minus 2 is 0, and 4 plus 5 is 9. And finally then, we end up with S prime plus the vector gives us S double prime. So that's S, which is 4, 1, plus the translation vector minus 2, 5. That will then produce S double prime. So 4 plus minus 2 is 2, and 1 plus 5 is 6. So these now become our new points for the translation. After the translation, so we've just translated the image after the reflection. So we're translating the white diagram to another section of the graph. So let's go ahead and plot that point here. What color can we use? Can we use blue? No. Can we use yellow? Let's use yellow here. All right. All right. So now we end up now plotting the point. So that's minus 1, 6. So that's minus 1 to my left and 6 up. So that's minus 1, 1, 2, 3, 4, 5, 6. So here, that's yellow. All right, so that's going to be P prime. So that's P prime. Oh, P double prime, pardon me. Then we're going to go ahead now and plot minus 1, 9. So that's minus 1 again, this direction. 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's here. So that's Q prime. Q double prime, pardon me. We're going to go ahead then and plot 0, 9. So that's 0, 9. So that's 0, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's going to be right here. So let's just move this label here out of the middle. All right. So I'm going to leave this over here, Q prime, Q double prime. That's going to be R double prime. And then now we're going to end up with, say here, 2, 6. So that's 2 to my right, 1, 2, up 6, 1, 2, 3, 4, 5, 6. So this is the shape that we end up with. So P, Q, R, and S double prime. So let me draw this here. So we're going to draw this here and draw this. Connect here and here, and here and here. And so you can see that the white diagram was then translated to going up in this direction here. All right. And that therefore then becomes our shape. The yellow one is the primary focus after the reflection. Normally when Csec gives you this question, their only focus is to see the yellow diagram and the green one. The white one is just the white one is just after the shape, after the reflection. Most times CXC is not really interested in that particular one then. All right, but I try to make this question as doable and as easy for the students to get. Later on in future tutorials, we're going to learn that this particular type of combined transformation is known as a glide reflection. A glide reflection is a reflection followed by a translation, or vice versa, a translation followed by a reflection. All right, so fantastic. That is exactly how we get that job done there. So hopefully you got some clarity on that. All right, so we're fast approaching the end of this particular video, but we have lots of work to do. So let's get into it here. We've calculated the coordinates of the images after the transformation, and we've drawn them on the graph sheet that was given to us. So we're good to go. All right, so beautiful. Let's move on to question 4. The diagram below has vertices K, L, M, N, which forms 2 separate isosceles triangles. We are to use the information and indicators on the diagram to find the missing angles, giving reasons for your answer. We are to find the angle LNK, the angle NLM, and KNM. Now, first thing that I want to make sure that I get clear with a lot of students, whether you've done geometry as yet or not, remember that whenever you're finding an angle, the angle is located at the letter that is in the middle. All right, the angle. So we're looking for the angle that is at N. We're also looking at another part of the angle that is at N, and we're looking for the angle that is at L. All right, so we're going to come back to that in a moment. Let's pull up our page that contains this diagram here. There is This is our diagram that we're asked. So it's L, K, L, M, N. All right. Right. So that's our diagram here. This is vertices L, vertices K, vertices N, and vertices M. All right. And then we're asked to find, firstly, we were asked to find, say here, angle LNK. So angle LNK. So that's angle LNK. We're looking for this angle here. This one that I've already highlighted for you here. We're looking for this angle here. This one inside here. Okay. And so when they say that we should use the indicators on the diagram, we're looking at these strokes. These strokes tend to means that the sides are of the same length. And this is not drawn to scale, just so you know. But according to the instruction, is that they are of the same length. Now, they did also mention that the two triangles that are adjoined together to form this this type of quadrilateral doesn't really, it kind of feels like a parallelogram, but it's not, because we're not sure if ln is parallel to km, and it's not drawn to scale. So it's a quadrilateral, but it's not, it's an irregular quadrilateral, that is. But one thing we know is that this particular quadrilateral here, this four-sided shape, basically is made up of two isosceles triangle. And so one of the geometric rule for an isosceles triangle is that if you have two equal sides, then it simply means that if this side has an angle that is 40, then it means that also this angle down here, which is what we're looking for, is also equal to 40. So easily then we can get to the answer that angle LNK is equal to 40 degrees. And the reason, the geometric reason for this is that triangle LKN is isosceles, therefore base angles are equal. That means that the angle at the base of this triangle here are going to be exactly the same. So right away we already know here that this angle here is 40 degrees. All right, so that was pretty easy. That wasn't too challenging then. Let's go ahead and look now at the next question, which requires us here to solve for, let's see here. Let's solve for NLM. NLM. So that's NLM. So NLNM. Okay, so that is angle L. Oh, I think I made an error with the label, guys. Oh, let's double check on that. I think I've made a mistake with the label. We're being asked to find NLM. 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 I think this is supposed to be K. I think the labeling is correct. So I think this is supposed to be K and this is supposed to be L. So LNK, that's still this angle, and LN. Okay, so angle L. Pardon me, guys, it's just a little confusing here. So I think it's supposed to be NLM. Gotcha. So NLM, we're looking for this angle down here. All right. Right, this is what we're looking for. So my error in this question is that I had labeled these two sides incorrectly, but we still remain intact here. So NLM, we're looking for this piece of angle at the bottom. And a couple students got it right, but their reasoning was incorrect. Now you need to recognize where the angle starts and it ends. The 140, even though you see it labeled at the top here, means that both of these small pieces here, this part up here and this part down here, they both measure 140. We're looking for the bottom half all right, and the bottom half, it doesn't mean that this line goes exactly through the center of 140. It's just that the both angles are adjacent, so the sum of both of these angles equal 140. Now if we can somehow find a portion of it, like about here, if you can find about here, then we can just take all of what we've just found in blue from 140, and to find the bottom half is what we're looking for. Now notice that the 140, a part of it is in the triangle at the top, KLN, which is isosceles, and we know that the bottom angles are 40, so we can therefore go ahead and start our calculation here by saying angle, let's find this top half here, angle KLN, so angle KLN, this piece here, angle KLN, this top half here, is in fact equal to 180 minus the 240s, so that's 40 times 2. So it's going to be 180 minus 80, which is equal to 100 degrees. All right. And so obviously the reasoning for this, the geometric reasoning, would have been the sum of the angles in a triangle sums to 180. So we can write that here. Okay, you have to write a geometric statement. So the sum of the angles in a triangle are supplementary. So that's the reason why we took it from 180. Right, because we know that 100 plus the 240s will give us 180. So this top half of the angle here measures 100 degrees. Therefore, if the whole entire angle measures 140, then it easily means that this angle here is equal to 140 minus 100 degrees, which is equal to 40 degrees. Reason being that both angles are adjacent, and they add up to 140 degrees, so they are adjacent angles. Okay, so this is what helps us to find. So a lot of my students struggle with writing the correct geometric reason. They had an idea and they have, hints of how to find the angle, but the reasoning was a challenge, which gives me the whole idea that I will need to go ahead and do a geometric video on how to find angles. All right, now next that we need to find then is say here, according to the question, we're looking to find KNM. Okay, so angle KNM, let me here guys, KNM, so angle KNM. So angle KNM, all of this angle here, both of these two pieces here. Now remember that we already know that this part here is 40 degrees, right? And we just learned that this here is actually 40. So we know that up here is 40. We just don't know what all of it is, and we can't say that this line chops it in two. We have no evidence of that. What we do have evidence of is the bottom triangle, which therefore also is another isosceles. Again, this is not drawn to scale, but what this means is that if we have an angle, if we have two sides equal, then it means that this angle here is going to be equal to that angle down here. So these two angles are going to be equal. Now, since they're equal, since this angle here and this angle here are equal because of the isosceles triangle principle, then it means that if I subtract 40 from 180 and divide it by 2, I would have gotten this bottom half here and also this piece down here. So I can go ahead and then I can say then, okay, angle L N M equals 100 minus 40 divided by 2, and that's equal to 140 divided by 2, and that's going to be 170 degrees each. All right, And obviously we know that the reasoning for that would have been that the sum of the angles in a triangle sums to 180. Or you could just simply say that triangle LNM is an isosceles triangle. We just went through that earlier. So that's why this bottom half here is 70 degrees. Now since we have this bottom half here which is 70 and this other top half here which is 40, then the angle to which we're looking for is equal to 70 degrees plus 40 degrees, and that's equal to 110 degrees. And that's the reason for that is that these two adjacent angles here sums to 110. All right, and that would be your reasoning, your geometric reasoning behind this particular question. So some of my students are not yet exposed to the topic. Some of you might have learned this a while back. This is the type of reasoning Csec is looking for when it comes to this particular question. You must be able to give a reasonable and logical explanation, geometric explanation as to how you get your answers, but you need the correct reasoning. Isosceles triangle, angles in a triangle measures 180, angles at a point in a straight line measure 180. You know, the whole base angles are equal, adjacent angles, understanding those basic angle principle. All right, so hopefully you guys finally got some clarity on how to approach this particular type of question. All right, we're then going to move on to the next part of the paper. As I said, we're fast approaching the end. We should get this wrap up in about 15 minutes, but let's not rush through. Okay, we're going to be looking at the variation aspect of this question then here. So part B, two variables x and y are related such that y varies inversely as the square of x. Key part here, many students keep forgetting to adjust the formula. Still, I find that a lot of the students were successful in writing down the correct formula, but still they were not able to follow the table, using the table method to solve this question. It says here, part 1, write an equation in x and y to describe the inverse variation where k is the constant of proportion. Now naturally then, we know that in order for us to answer this question, we need a formula, a variation formula. Now the general formula for inverse variation is that y is equal to k divided by x. That's the general rule, all right, general rule. But because they say that y varies inversely as the square of x, then you're going to find that this becomes x squared here. All right, so this then becomes the formula that we are now working with, the adjusted formula. And it so happens that we got 1 mark just to write down that formula. It says write an equation in terms of y, write an equation in terms of y involving x and where k is the constant of proportion. So 1 mark just to write down the correct formula. Then of course we get another mark to find the value of k. So here we have y is equal to k divided by x squared. As instructed, you have to use the part of the table that gives you the already known values to create the, in fact, value of k here. So now if you look at this first part of the table here, you're told that x is 6 and y is 4. So we're going to replace y here with 4. We obviously do not know what k is because that's what we're searching for. And we have x here to be equal to 6, but it becomes 6 squared. I had one student who wrote the square of x as the square root of x. All right, square root and square is different, so you have to make note of that, guys. So the square of x, 4 is actually equal to k divided by 36. And when the unknown variable is at the top of the equation, we're going to simply multiply, say here, 4 times 36. Mathematically, that works out that k is equal to 144. All right, beautiful. So that is how we find the value of k. Now, it did say that we should go ahead and fill out the table. So we're now going to calculate r. R is now the variable that is representing y. So if you go back and rewrite back our original formula, then you're going to find that y is equal to the k divided by x squared. That's our original formula. Y is being represented by r. So I'm going to go ahead and just replace the y here and put r here instead. So r is equal to k divided by x squared. So now r is equal to k, which we now know is 144, divided by x, which is obviously 3.9. It's in the row where x is, so that's 3.9, and that's going to be 3.9 squared. Okay, so r then is equal to 144 divided by, I believe this is 15.21, if I remember my calculation. So therefore r is actually equal to say here, I think it was 9.4. I believe that's what it is. Yes, 9.4. Let's double check on that. So that's going to be 144 divided by 15.21, 9.46 or 9.5. So 9.4, 9.5, 9.56, whichever one is acceptable. I'm going to go ahead, I'm going to write 9.5. All right. Beautiful. And so we're going to go ahead then and work out the value of f. F is now in the row where x is. So right back our original formula, y is equal to k divided by x squared. In this case here, y is known. K is actually equal to k. And then we're going to go ahead then and adjust this formula here. So y remains as y. K remains as k. But this becomes, say here, remove x squared. I'm going to put f squared because f is now representing x. It becomes, instead of x squared, we have f squared. Y is therefore equal to 18. So that's 18 is equal to k, we know is 144 divided by f squared. Now, when your unknown is at the bottom of the equation, we do quickly here multiply both sides by f squared. That takes a bit of time. So just going to do a swap. Okay, you're allowed to do a swap. So if the unknown variable is at the bottom, we can just put it where the 18 is, and we can also go ahead and just put the f square where the 18 is and put the 18 where the f square was. All right. So therefore now we end up with f squared being equal to 144 divided by 18 is equal to 8, and so f is equal to the square root of 8. All right. So this would actually be 2 root 2. If you want to leave your answer in third form, or it would simply be, I believe, 2.31. Let's double check on that. Shift square root of 8. That's 2.82. So f then is equal to 2.82. All right, or 2.83 rounded off to 2 decimal places or 3 significant figures. All right, so wow, nice question there. Nice. I think it was 6 marks, 1 mark for the formula, 1 mark for finding k. I think finding k requires a bit more mark, but it's okay. 1 mark for finding the formula, 1 mark for finding k. That's 2 marks for r and 2 marks for y. So that is a nice solid 6 marks in the exam. All right, so beautiful question then there. All right, let's move on then to the latter half of the paper. We're closing out the paper. As I said, we're going to be here for about a little bit over an hour and a half, which is the maximum time that all my students were given to work this paper then. All right, so last question here, guys. Let's dive right on into it. We have the point T is minus 2, 4. Q is 3, negative 2, and R is minus 1, 1 are distinct points plotted on the Cartesian plane. And when I wrote optional here, it was explained to my student that it was optional if they wanted to go on the graph. Right, this particular question doesn't necessarily need a graph. You can actually work it out without a graph. All right, we are to determine the following: the slope of QR. All right, so I've already written down my points here for you. All right, I've written down my points here for you. They're around here. So we already have it down here that T is minus 2, 4. Let's transfer it around here. So T is minus 2, 4. T is equal to minus 2, 4. Q is in fact equal to 3, negative 2. 3, negative 2. And R is equal to minus 1, minus 1. All right, so we need to find the slope of QR. We know that slope and gradient is the same thing. So the formula for gradient is y2 minus y1 divided by x2 minus x1. Now, of course, what I find that a lot of my students are still rushing the process. they're not labeling their points, and this was one of the downfall. They didn't label the points, so they obviously made a mistake in putting down the incorrect values, which led to the incorrect result. So here I strongly recommend that you identify the points that you're using. So here and here, QR, so that's going to be your X1 and your Y1, and that's going to be your X2 and your Y2. Failure to label the points will, you're basically giving yourself you're opening the opportunity for you to make basic errors if you don't know, or if you don't know what you're doing, or you're not confident in what you're doing. So you have to label your points, ladies and gentlemen, boys and girls. Let's get into it. So Y minus Y1, so that is Y2, which is -1, minus Y1, which is a -2, so that's -1 minus -2, all divided by X2, which is -1, take away X1, which is 3. All right, once you label your points correctly and you plot them down, should be ABC from here. Negative by negative is a positive, so that's -1 plus 2 is 1, and -1 minus 3 is in fact -4. So my answer here for the slope of QR is in fact -1/4. All right, so easy question there. We're going to move on next then to finding the length of TR. So now we're changing the points that we're using. We know that the length formula is in fact Pythagoras theorem using on the Cartesian plane. So that is going to be Y2 minus Y1 squared plus X2 minus X1 squared. A lot of my students did not get this question right for one simple reason. They struggle. Most people struggle in remembering the formulas for these questions. It's just so very unfortunate that CXC does not provide this formula on the exam. So you guys will have to form teams, form groups, friend groups, study groups, and try to get the formulas somewhere up into your cerebrum. Okay, because without the formula, the question is near impossible to attain the answer. All right, so once again, we're going to be changing the use of our X1 and Y1 here, because now we're looking at T and R. So we're going to be changing this X1 over here, and we're going to be moving this X1, Y1 to T. All right, so that's going to be my X1 and my Y1 here. So that's X1, Y1. I'm using T and Q, T and R. So TR is going to be, so T is going to be X1, Y1, and R is going to remain as X2, Y2 here. So Y2 is -1 minus Y2, Y1 is 4. And I'm going to square this. Plus X2 is -1. Take away X1 is -2. So that's -1, take away -2. We're going to square that result here. All right. So then we move on next to, say here, square root of -1 minus 4 is -5. I'm going to put it back in a bracket and squared. And that's going to be -1. Negative by negative is positive. So that's -1 plus 2. -1 plus 2 is in fact 1. So that's 1 squared. So we end up with the square root of, when you square anything, you're going to get a positive number. So that's 25. And of course, when you square 1, you're going to get 1. So you end up with the root of 26. So you could say root 26 units, or what most of my students wrote down was, in fact, say here, 5.05. All right, that's what they wrote down as their answer. So 5.05 units. So you could leave it as root 26 units, or you can go ahead and write 5.05 units. And as I said, without the formula, guys, this question is near impossible to work out. You must give the formulas a time to get into your cranium, into your cerebrum, and it needs to get there and stay there. All right. Moving right along, guys, we're going to wrap this video up in a moment. Do not forget to hit the subscribe button below. Hit the like button whether this video is of any value to you or not. Surely you're getting a lot of understanding here going forward. So hit that like button, guys, before you leave off this video. Now we're going to move on to equation of QR. We know that the equation of any line is in fact y equal mx plus c. All right, now we already have m because m represents our gradient, and the first question that we did was that we were asked to calculate the slope of QR, which is the gradient of QR. So we already know that m is equal to a quarter or minus a quarter. All right, obviously we're looking for Q and R, so we're going to be using either the bracket, the point Q, or the point R. I don't like using negative, as you would already seen from my early explanation about avoiding negative numbers. I am going to just use 3 and minus 2 here as my x and my y. So y is going to be minus 2. Remember that every point is always going to be x comma y. All right, so that's y1 x1, so that's y is minus 2. So that's going to be minus 2 here. And that's equal to m, which we know already is a quarter, multiplied by x now, which we now know is 3 plus c. All right, so now minus 2 then is equal to, nothing can be cancelled in the middle here, so that becomes minus 1 times 3, that's minus 3 over 4 plus c. All right, so c then, we're going to transpose the minus 3 over 4, so it's going to become minus 2, so c is equal to minus 2, bring this over, it becomes plus 3 over 4, and obviously we have to find the LCM here, which works out to be minus 8 plus 3 over 4, the LCM is 4, so when we do the calculation we end up with c being equal here to minus 5 over 4. Just go ahead and put this over 1 and find your LCM and do your fancy stuff. So you end up with c being equal to minus 5 over 4. But you need to make sure that you form a conclusion here, because c is a requirement, but what they ask you for is the equation of the line. So therefore the equation is y equal, say here, m, which is minus a quarter, x, and c works out to be minus 5 over 4. So this is what Csec wants, the equation of the line. All right, but you had to find c, and of course you already knew what m was, so that takes care of that. And so finally, well, not finally, here we have 2 more questions. All right, so we're going to be looking at the midpoint of TQ. So now we're going to be using T and Q. So we're going to be changing this here and making this Q here my x2, y2. We're looking at TQ now. So TQ is, so T is going to be the x1, y1, and Q is going to be the x2, y2 here. We're looking for the midpoint. Midpoint formula is x1 plus x2 over 2, comma, y1 plus y2 over 2. They're both in a huge bracket here. So x1 plus x2, what we're looking at here is x1, which is minus 2, plus x2, which is 3. So that's minus 2 plus 3, or divided by 2, comma, y1 plus y2, that's going to be 4 plus negative 2. So that's 4 plus negative 2, 4 plus negative 2 over 2. So that's minus 2 plus 3, that's equal to 1 over 2, comma, 4 plus minus 2 is 2, and 2 over 2 is equal to 1. So my midpoint here is a half 1, 0.51. So that's my midpoint. All right. So as you can see here, guys, of course, if you, I have 3 videos on this particular topic that I went through coordinate geometry extensively in details. Please check out part 1, part 2, and part 3 of the coordinate geometry video on my playlist below, and you will be able to get a full, complete understanding of this particular topic here. You're going to be learning some in-depth knowledge about coordinate geometry, so do check that out. I will pin or link it in the description box below. All right, and finally, then, to wrap this up here, we're looking at finding the equation of the line that is perpendicular to QR, and it's actually passing through the midpoint of TQ. All right, so try to add a little bit of twist to the question here. Normally, it kind of tells you that it's passing through a specific point, or it's passing through the midpoint of the actual line, all that fancy stuff. I tried to twist up the question a little bit here for my students. So we know that, of course, the equation of any line is y equal mx plus c. But the thing is, the m that we're looking for here is in fact the perpendicular gradient m2. So just skipping through, as I said, if you want a thorough review on this, you can actually go ahead and check that out. But m2 is going to be equal to -1 divided by the gradient of m1, which is already we know is a quarter. Okay. Sorry, so m1 we already know was a quarter, right? And now it's going to be -1 multiplied by -4 because you have to flip. So then we end up with a gradient here of 4. All right, the gradient here is in fact 4. All right, so now that we have the perpendicular gradient m2, we know that we're going to be using, say here, it's passing through TQ. TQ, we already know that TQ is a half 1. So this is my x and this is my y. So x is a half, y is 1. We're going to go here and put 1 for y. And we know that m is 4 and x is a half plus c. All right. So m is 4, new gradient. X is a half because it's passing through TQ, and TQ is a half comma 1. So a half of 4 is 2. So we have 1 is equal to 2 plus c. Easily then we know that c is equal to 1 take away 2. C is equal to -1. So that's our solution to that question. I do apologize for, kind of chucking up the answers a little bit, but that's what it is. All right, like I said, there's a complete tutorial on this. Check it out, guys, if you need a bit more clarity on that particular lesson then. And that brings us to the end of this paper. Pardon me, I didn't make the conclusion. The conclusion is that y is equal to 4x minus 1. That's the equation of the perpendicular line passing through TQ. All right, or the midpoint of TQ. All right, so I want to thank you guys so much for spending 1 hour and 40 minutes with me here. I do hope that the tutorial was of good value, good use to you. Use this knowledge going into your remaining exams, and so that you can be more efficient and score a higher grade than what you've already done here today. All right, so thank you guys so much for watching, and I'll see you next time. Do check the description box below. You'll find details to all my online classes, my tutorial, and all the information in how you can get in touch with me to get into my live sessions. So until then, take care. Next time, do not forget to hit the subscribe button below and leave your thoughts and comments down below. So until next time, take care and keep on practicing. Bye bye, guys.